Welcome to Mr. Chao Time. This is Unit 1, Rational Numbers, Lesson 1, A Plan for Solving Problems. So, what is a plan for solving problems? Well, you can use the 4-step plan. The 4-step plan will look familiar to those of you who took design class last year because it is identical. The only difference is that we're doing it for math, I suppose. So, step 1, understanding the problem, asking questions. When you look at the question, you need to understand what parts of the question you need to know. This might be things like facts, figures, which is another word for numbers. This might sometimes be research that you have to do, because sometimes what you need to find or the answer that you need to give might not be apparent in the question. If you're finding the area of some space and you're given the dimensions in kilometers, but you need to give the answer in hectares, then you might have to do research to find out what the conversion rate is. And you might need to even just find out what a hectare is. Once you have all of your relevant information, you need to then formulate a plan, which means to determine a strategy using the relevant facts that you found in step 1. This might be something like writing an equation or an expression, or writing or drawing a diagram, or creating a table or a chart, or something along those lines. When you have your plan, you then execute the plan. You solve the problem, use the plan to solve the problem. Finally, you check your answer. You can examine your answer for reasonableness several ways. You can estimate. You can solve it a different way. Or you can solve it again. There are other ways too, but here are just some suggestions. All right, so let's look at some examples. If you're following along with me in the book, this will be page 2 and page 3. So on page 3, refer to the table at the beginning of the lesson on page 2. About how many times as great is the number of teens who use their cell phones to take pictures compared to the number who exchange videos. Use the 4-step plan. So, step number 1, understand. What do you need to know? Well, you need to know the number of teens that use cell phones to take pictures. You need to know the number of teens who use cell phones to exchange videos. You need to be aware of this word about, because that's going to tell you how you're going to solve the problem. And then you need to know this phrase, how many times as great, because that's telling you the operation that you're going to use. And what are you comparing? How many times as great? What two groups are you comparing? Well, the cell phone group, the take picture group and the exchange videos group. So let's make our plan. We know that we need to divide the number of teens who take pictures because we need to know how many times is great. Oh, and this right here, here's a little tip. The phrase how many times is great means you should use division to compare the numbers. The phrase how many times more means you should use subtraction. So how many times is great means how many times does the number fit into the other number. And that is division. Because we're asking about, we are doing an estimation. So our groups are taking pictures, 177, exchanging videos, 61. 177 is about 180, 61 is about 60. How many times does 60 fit into 180? That's what it's asking. Well, 3. So the number of teens who use a cell phone to take pictures is about 3 times as great as the number who exchange videos. You could go back and solve it again, or you can solve it with the real numbers, You could try to find a different way of solving it, although there's not really that many other ways of solving it. So yes, this answer is reasonable. Let's do it one more time together. About how many more teens in the survey use cell phones to play games than access social network sites? Again, we're looking at this word about, which means we're going to estimate. We're looking this time at playing games and social network sites. About how many more? We know that's subtraction. Sometimes you can just use simple numbers to think about this in your mind. So if Mr. Chao had 4 apples and you had 2 apples, about how many more, or exactly how many more do I have? How many more? I have 2 more. You can just do that in your head, right? Well, what operation did you have to use? Subtract. So that's one way that you can figure out the operation that you need to use. So 92 is about 90. 46 is about 45. We're subtracting, so the answer is 45. 45 more teens. Use your phone to play games compared to accessing social network sites. About 45. We could do the real math. 92 minus 46 is 46. 46 is pretty close to 45. We could do it again. We could do it different. Any one of those ways to check our answer. Great. Let's move on. Solving multi-step problems. Sometimes solving a multi-step problem requires 2 or more substeps. Let's look at example number 2. The tower of a free-fall ride in an amusement park is 251.5 feet tall. The ride begins to free-fall from 18.9 feet below the top of the tower, and the brakes are applied at 41.4 feet from the bottom. How long is the free-fall portion of the ride? Free-fall, for those of you who don't know, is when you're falling and nothing is stopping you. So what do we know? Step number 1. Well, the tower is 251.5 feet tall. We know that the ride doesn't go up to the very, very top of the tower, though. It stops at 18.9 feet. And then it breaks at 41.4 feet, which means you're no longer in free fall because something is slowing you down. So, Our plan is going to be to draw a diagram. We're going to subtract the 251 feet. This is the total distance. We're going to take out the very top and the very bottom where the brakes are applied, and what's left is the free fall. So 251.5 minus 18.9 is 232.6. We're going to take that, we're going to subtract the very bottom where the brakes have been applied, which is 41.4 feet. And we're going to get 191.2. So the free fall is 191.2 feet. This is the answer. To check, we could estimate 20 plus 40 plus 190, which is the answer we got, is 250. That's pretty close to 251.5. So that answer is reasonable. So let's take a look at the next got it question. A rectangular garden is 12 meters long and 9 meters wide. A border is sold in 1.5 meter sections. A border is something that goes around the edge of the shape. How many sections are needed to surround the garden? Well, we know that if we're going to go around a shape like a rectangle, this idea is called the perimeter. Right? And we also know, or if you don't know, you can look this up, perimeter is equal to 2 times the length plus 2 times the width. But is that what we're finding, the perimeter? No. We're finding how many sections are needed to go around the garden. So these sections are going to go around the garden, right? And we're finding how many of these sections go into the total perimeter. How many times this will fit in? How many times? We saw earlier that that was division, right? So we're going to take whatever this p is, and we're going to divide it by 1.5. And that's going to give us the number of sections. Okay? So we could draw this out, or we can just use arithmetic, which is what I would like to do, which is just use the numbers. So we'll just plug these numbers in. 2 times 12 plus 2 times 9, that is equal to the perimeter. 2 times 12 is 24. 2 times 9 is 18, equals 42. Then we take p and we divide by 1.5. So 42 divided by 1.5. So that's 420 divided by 15. 15 goes into 42 2 times. 30. 12, bring down the 0. 120. 5 goes into 120 8 times. So we need 28 sections. How can we check our work? Well, I'm going to delete these little fence things that I drew here. Okay. The fence is going to go into these sections, right? So another way we could do it is find out how many sections go into 12 and how many sections go into 9. Well, how many 1.9 meter sections go into 9? 9 divided by 1.5 is, let's see, 2 times is 3, 6 times. And then how many into 12? 12 is 8. So 8 sections will go into this side. What I did is I divided 12 by 1.5 to get 8, and then 9 by 1.5 to get 6. So we know we need 8 for this side, which means we also need 8 for this side. We need 6 here and 6 here. Oops. So if we do 8 plus 8 plus 6 plus 6, that equals 16. This equals 12. Yep, it's 28. So our work checks out. We need 28 sections. Do I have that written somewhere? Yeah, right here. 28 sections. And that's it. I hope you enjoyed this first episode. See you in class. Bye, y'all.